Hello guys, welcome to my YouTube channel Chemical Hub, and today we are going to discuss about advantages and some disadvantages of V205 in the sulfuric acid industry. As we have seen in the previous video about how sulfuric acid is manufactured, so now let's continue forward with the advantages of V205. The first advantage is that it is immune to poisoning. Second, it is required in less amount, means that almost 10 kg of V205 is required to manufacture about 1 ton of H2SO4. The third advantage is that it requires very low initial capital investment. Fourth, only 5% of V205 is to be replaced per year. Now let us discuss some disadvantages of V205. V205 is less reactive, and so we use dilute SO2, which is about 7 to 10% to make it more reactive. And to make it more reactive, actually we require large converters, and so high initial investment is required to dilute and make it more reactive. So this is the major disadvantage of V205. How is V205 actually used? It is dispersed in a porous carrier in pellet form and it is used. Why is platinum not used in this manufacturing of sulfuric acid? The reasons are: first, easy poisoning; second, fragility, which means it gets broken into pieces very quickly; third, rapid heat deactivation, means high amount of heat can make it inactive as a catalyst. Fourth, high cost of initial investment, as platinum is a costly metal. Now let us discuss some comparison about chamber process and contact process. First, chamber process was previously used while contact process is used in present day. Second, almost less than 80% concentration of sulfuric acid is manufactured using chamber process, while greater than 98% concentration of sulfuric acid can be achieved using this contact process. Third, homogeneous catalysts like nitric acid or any other oxides of nitrogen can be used in chamber process, while in contact process, heterogeneous catalysts such as V205 in solid pellet form is used. Now let us discuss about the kinetics and thermodynamics of this process. The step number 2 of this reaction, that is preparation of SO3, is the slowest and rate determining step of this reaction. The reaction is 2SO2 plus O2 in presence of catalyst V205 gives 2SO3. This is an exothermic reaction, so temperature required should be low as possible. So we keep optimum temperature up to 400 to 500 degrees Celsius, which is more favorable. Delta Ng, that is the difference in the number of moles of reactants and products, is -1. So high pressure is required, that is about 1.5 to 1.7 atm. This data can be obtained using Le-Chatelier's principle. Equilibrium constant. The equilibrium constant for this reaction can be given by Kp equal to partial pressure of SO3 square upon partial pressure of SO2 square multiplied by partial pressure of O2. Do like, share and subscribe for more such content. Thank you.